Today was the first day that we did work with sample proportions, sampling distribution of proportions. So I gave them this problem. So, as time goes forward, more and more companies are going to be able to provide tests that will ascertain whether or not potential employees have aptitudes for certain things, even though they might never have done them. So they might be able to give a 20-minute task that will help to determine if a person really has computer coding aptitude, even though they've never done computer coding. So if we randomly select 40 applicants, what's the probability that more than 30% of them would have computer coding aptitude? Well, the way we break this problem down is, you can see I underlined the 40 applicants. That says, ooh, we're taking a sample. I'll bet we're dealing with either sampling distributions of means or proportions. Which is it? I can't wait to find out. By golly, there it is. We're talking about 30%. We're talking about a proportion of the sample having computer coding aptitude. So that's good. But then if we look at this problem, what's the parameter? And the answer is it's the 35%. That's a statement of fact. So we're going to say, oh, that's the true proportion P, and we're going to use the sampling distribution of proportions to be able to help us figure this out. Now, requirements to be normal. For a mean average, either the population's normal or the sample size has to be at least 30. And then for the proportions, those are the requirements that we need. So what we need is the sampling distribution of proportions of employees with computer computation, distributed normally with the parameter of 0.35 as the mean, and then we follow the standard deviation formula. We just do that off the formula sheet. So there is our population, there's our sampling distribution rather. There's the work shown, and you can see 0.748 when we use the normal CDF is the probability that in a random sample of 40 applicants, at least 30% of them would have computer aptitude.